What if I told you the US military can arrive in one of the most remote places on Earth, look at a piece of empty terrain, and begin turning it into an aircraft operating area? No airport, no concrete runway stretching for miles, no massive construction project that takes years, just engineers, specialized equipment, and thousands of pieces of military infrastructure designed to go together like a giant puzzle. And before long, aircraft can be operating from a location that previously had almost nothing. It sounds almost impossible. But the fascinating part is that the US military doesn't actually need to build an airport the same way a civilian government would. Instead, it has developed an entirely different philosophy: make the airfield portable. And once you understand how this works, you start to realize that the runway may actually be one of the least interesting parts of the whole system. Because an airfield isn't just a strip of pavement. It's an entire ecosystem. Aircraft need somewhere to land. They need somewhere to park. They need fuel. They need maintenance. They need ammunition if they're conducting combat operations. They need lighting. They need communications. They need people. They need protection. And they need a surface strong enough to handle the enormous forces created when an aircraft weighing tens of thousands of pounds touches down. So how does the US military solve all of this when the nearest permanent airbase could be hundreds of miles away? The answer starts with something that looks surprisingly ordinary: metal panels. For decades, the US military has used specialized expeditionary airfield matting to create aircraft operating surfaces in locations where conventional construction isn't practical. One of the best-known systems is called AM2. At first glance, AM2 doesn't look particularly revolutionary. They're essentially large aluminum panels designed to connect together. But individually, a panel is just a piece of metal. Thousands of them, properly installed and supported, can become something much more useful: a runway, a taxiway, an aircraft parking area, or an aircraft operating pad. Think about the difference. A conventional runway is basically permanent infrastructure. You prepare the ground, build the foundation, install layers of material, construct the pavement, add drainage, markings, lighting, and supporting infrastructure. That can be an enormous engineering project. Expeditionary airfield systems approach the problem differently. Instead of permanently changing the landscape, military engineers bring much of the surface with them. It's essentially infrastructure that travels with the force. But there is an important misconception here. You can't simply land at an empty field, throw down some aluminum panels, and immediately start launching fighter jets. The preparation can be extensive. Before construction begins, engineers have to understand what they're working with. How strong is the soil? Is the ground stable? Will it drain properly? Are there slopes? Are there obstacles? How much space is available? What type of aircraft will operate there? How much runway length is required? But where will aircraft park? Where will fuel and equipment go? These questions matter because aircraft don't care that you're operating in an emergency. Physics still applies. A fighter jet landing on a poorly prepared surface can turn a temporary airfield into a very expensive disaster. That's why expeditionary airfield construction begins with engineering and planning. The terrain is evaluated, the area is prepared, and only then does the modular surface start going down. This is where the concept becomes visually impressive. Imagine looking across a remote piece of land. At first, there is nothing there. Then military vehicles arrive. Equipment is unloaded. Engineers begin preparing the site. Panels start appearing. One connects to another, then another, and another. Slowly, the empty ground begins to disappear underneath a huge metallic surface. The result can look almost like someone has assembled an enormous metal carpet. But this carpet is designed for aircraft, and the interlocking design is critical. The panels have to work together as a system rather than as individual pieces. That gives engineers the ability to create large continuous operating surfaces from modular components. The Marine Corps has used AM2 matting for expeditionary airfield applications for decades, and military documentation describes the system being used for runways, taxiways, parking areas, and other aircraft operating surfaces. In fact, one of the biggest problems with expeditionary airfield matting is simply its weight. The more runway you want, the more material you have to transport. And if you're operating somewhere extremely remote, every additional ton creates another logistical problem. This is one reason military engineers have continued looking for lighter and more efficient airfield systems. The aircraft may be the visible part of the operation, but behind that aircraft is an enormous logistical machine. And the same philosophy can be seen in other parts of American military aviation. Instead of assuming that every aircraft will always operate from a massive permanent base, the military has increasingly explored ways to distribute aviation operations. This concept is especially important because large permanent air bases are valuable, but they are also predictable. A permanent runway can't move. Its location is known, its infrastructure is visible, and if an adversary knows where aircraft are concentrated, that base can become a very important target. Dispersing aircraft across multiple locations can complicate that problem. Instead of having dozens of aircraft sitting together at one enormous facility, some aircraft can potentially operate from smaller and more dispersed locations when operationally suitable. This is one reason concepts such as expeditionary airfields, austere operating locations, and agile aviation operations have become increasingly important in military planning. Think about it this way. A permanent airbase is like a giant fortress. It has hardened facilities, enormous runways, hangars, fuel infrastructure, maintenance facilities, command centers, and thousands of people. It's incredibly capable, but it's also expensive and fixed in place. An expeditionary airfield is almost the opposite. It's smaller, it's temporary, it's modular, and it can potentially be established closer to where operations are taking place. Now, there's another piece of the puzzle that most people never think about: runway lighting. Imagine trying to operate aircraft from a remote location at night. A metal runway sitting in darkness isn't exactly useful. Pilots need visual references. Ground crews need to work safely. Aircraft need to move around the operating area. And the entire operation needs to function under conditions that a normal airport takes for granted. That's why expeditionary airfield equipment can include specialized lighting and other systems designed to make temporary aviation operations possible. The fascinating thing is that the U.S. military has developed an entire system for rapidly creating aviation capability where permanent infrastructure may not exist, and the system extends far beyond the runway. It includes engineers, logistics, transportation, power, fuel, communications, aircraft maintenance, security, air traffic procedures, lighting, and of course, the aircraft themselves. Without all of those pieces, the runway is just a metal surface sitting on the ground. With all of them working together, that same surface can become a forward node in a much larger military network. And that's what makes expeditionary airfields so interesting. They change the meaning of distance. A remote location without an airport might look strategically irrelevant. But if the military can establish an operating area there, even temporarily, the location becomes much more useful. Suddenly, aircraft don't necessarily have to fly all the way back to a major permanent base after every mission.